Okay, so we're going to be discussing quadratics today, okay? And I'm going to take us through a series of different things, making sure you guys are aware of a little bit about graphing quadratics, a little bit of how to get it into that right kind of graphing form, and a couple other little details that we'll get into. So anyway, so let's just see how this plays out. So I want to recall back from your days in both Math 2 and Algebra 2, we're going to talk about graphing quadratics. So hopefully you guys remember well that if you were graphing an equation like y equals 2 parentheses x minus 1 squared minus 5. Let's just say that was...
Excuse me, Mr. Penner.
Is it not showing up?
No.
Okay,
No.
How about now? Is it showing up now?
Yes.
Okay, perfect. So let's say we're looking at 2 parentheses x minus 1 quantity squared minus 5. So can you guys tell me a little bit about where you would start that journey? You'd start at 1, negative 5, wouldn't you? And so we'd be sitting over here, 1, 2, 3, 4, 5. So that's my vertex of 1, negative 5, right? Do you guys remember how you would actually usually graph that back from your days in both Math 2 and Algebra 2? Anybody remember what you used to do from your vertex? Yeah, we had this nice little 1, 3, 5 pattern, which means in this particular case, because we threw this 2 in front, instead of moving over 1 up 1 and over 1 up 3, what are we going to do? Over 1 up 2, and then over 1 up 6, and then over 1 up 10. So there's 2. I think that's going to be enough right there. And I think we have a pretty nice looking graph right there. Are you guys all right with that little bit of an idea? Pretty simple little concept. I am personally kind of into having people label things like writing the coordinates down that we just found, 2, negative 3 and 0, negative 3. But what a lot of people don't realize is that if we're looking at the parent function x squared, because of the 12 big functions, this is the square function, is it not? So let's talk about what happened to f of x. What is this graph? What happened to it? Let's talk about the transformations that happened. Well, the first transformation that happened is somebody said, hey, let's multiply it by 2, didn't they? What other transformation happened? Yeah, somebody said, hey, let's move it down 5 units. There's one more transformation that happened, something that happened on the inside of the function. What is it? The x minus 1. So let's go back and think about the concept of how this played out. And I'm not going to plot that one point, but let's imagine we had this point A on the original function, which was the coordinate 3, 9. Can you guys help me figure out what the new point would be on 3, 9? Let's talk about what happened. So let's look at this right here. Don't look at the big equation. Let's literally just look at this statement there. What does the 2 on the outside do? It doubles the y. So 9 became what? 18. And then what did the 5 do? It subtracted 5, so it became 13. You guys cool with that? What's going to happen to the x value? What did 3 become? Oh, it became 4. Now, by the way, could we check that to see how we did? Let's try it. What is 4 minus 1? 3 squared is 9. 9 times 2 is 18. 18 minus 5 is 13. See, but I got the coordinate 4, 13 without ever plugging anything up here. I plugged it into the original function and just thought of the original squaring function. So with that in mind, I would like you to take this one right here. So you have y equals negative 3 parentheses x plus 4 squared plus 2. I would like you to write that in function form. And I would like you to take the coordinate negative 3, 9, and I would like you to figure out what your new value would be that would go with that. So again, I'm wanting you to write it in that transformation kind of function notation. All right. So somebody help me out. Where does the -3 go? In front of F. Yep. True. How about the 4? Where is that going to be? That's inside the parentheses. That's still x plus 4. It's a composite, isn't it? Replace x with x plus 4. No big deal. That's what we did. And then how about the plus 2? Very, very end. Okay, so who can do the x part for me? What's going to happen to x? Who's got it? We're just going to subtract 4. You got it, -7. What's going to happen to y? 2 things. Remember, y is compliant. It does exactly what it says it wants to do. So what's it going to be? What's first to the 9? It's going to turn into -27. -25, you follow me? So that's what's going to happen on the quiz that's in tomorrow. On the quiz tomorrow, when you turn in your homework, I need you to be able to actually do this kind of thing right there with something to say what you know it would be. Now, would you guys be able to graph this? What are you going to do to your 1, 3, 5 pattern? It's going to be -3. Ooh, it's going to go way down, isn't it? Very, very quickly. So no way you have started to raise your hand. Yeah, actually 100%. Yeah, when you go through the process of graphing by transformation, you always do any multiplicative idea first, and then additive or subtractive ideas second. That's a good question. Now, as it turns out with parabolas, you really, it's a little bit simpler than it is for some other shapes, but I always do all of the x's and then all the y's, or I do all the y's and then all the x's, but I do the multiplication step first and then the additive or subtractive step last. It's just PEMDAS. And the p and the e are actually buried in the composite function itself. The parent function had the square, didn't it? So I'm not really dealing with that portion. Now, unfortunately, guys, here's the deal. Sometimes someone is mean to you and they do not hand it to you in this nice, easy format like this where you can tell what it is. So in your homework today, I'm going to have you do some problems where you can look at them and you totally will know what's going on, and others like this one where you may not know. So can you guys see anything right now? What was the vertical stretch factor? Anybody got an idea? It's 2. Got that. Anybody know what the vertical up and down part is? Is it 43? I don't really know. But I do know that the 2 part, that part's good. So there's a couple of ways that we could play with this. The first one is using the axis of symmetry. So I think you guys probably have a little bit of a recollection of the axis of symmetry. It's a little piece of the quadratic formula, which was supposed to be x equals opposite b over 2a, which in this case, what is opposite b? It's -20. And 2a would be 4. So it looks to me like my axis of symmetry is at -5. Now, what you guys are supposed to do every single time is you're supposed to find opposite b over 2a, and then you're supposed to plug that back into the original function. And if you do that, this right here will be your vertex. So let's see what happens. What would happen, everybody, if we plugged -5 back into the original problem? That's not hard to do, right? I mean, we could do that. What happens if I plug in -5 into the original question. We do have some order of operations to handle, don't we? So what do you guys see right here? Careful about this. I got -5 squared, I got a times 2. Do we square and then times, or times and square? Square then times, right? So this would be positive 25 times 2, that's 50. And what about this one right here? -100, 43. So if I put all this together, I look like I've got -50 plus 43 is -7. So ladies and gentlemen, we have what we need. If we know where the vertex is, what did the graph do then? If the vertex is at -5, -7, somebody moved it to the left 5. What did they also do? They moved it down 7. So isn't this then the function? Could somebody tell me what to put in there? It's x plus 5 squared. Somebody moved it down 7. And what's sitting in front that's actually going to make this thing go? A 2. Hey, so we just took it from the bad form, the non-graphing form, and we turned it into the form that we like, which was the form f of. So do we know what happened to it? If we took x squared, what do we do to every single coordinate is we just moved them to the left 5. What else did we do? We doubled all the y values and we took away 7. Do you guys think you could handle that? So if somebody hands it to you in the wrong form, can you make it in the right form that's easy to graph? So I want you to do one of these for me, just one. Don't want to do very much of it. Your problem is going to be this guy right here. Your g of x that you're going to try to modify is 3x squared minus 12x plus 7. Okay? Simple little problem. I'm not going to have us graph them because we already did that. I just want to make sure you can get it into that nice graphing by transformation form. I actually did square it already because I plugged in 2. Did you guys get -5 when you plugged it back in? Okay, so can somebody help me write it? Hiram, can you write it the good way? Can you write it the good way? So like write it in the right form so it looks like, you know, this kind of thing, so it's a little bit easier to understand. Wait a minute. -2? Yeah, you got the 2 mixed up, squared. And then what? -5? Now, I gotta say there's a couple of things that are here that if you've never seen this before, there's something that I do want you to know. If you did this right, something will happen every time. So when you did your opposite b over 2a and you got -5 and you went and plugged in, you see these two values? So look at them real carefully. You got a 50 and a negative. I'm ignoring the 43 because I don't care about it. But look at those two. 50 and -100. Look at those two, 12 and negative 24. Do you notice anything about those two values? One of them is always twice as big as the other, is it not? And also, if one of them is positive, what's the other one going to be? So if you have done it right, if this number right here was, say, a negative 8, what's this one going to be? A positive 16. If you have done it right, that's what will happen every time. And if that doesn't happen, then I would look back and make sure you chose correctly here. Does that make sense, everybody? Not a big deal. Now, honestly, I hate doing it that way. And there's a reason I don't like doing it that way. I do need you to understand that that's a good way to do it, but there's a better way called completing the square. So, in completing the square, this is a skill that if you have avoided it, some people back in Algebra 2 and whatnot, they avoid completing the square because they think it's just too hard, like they used to avoid fractions. Please, please, for goodness sakes, do not avoid completing the square. So I'm going to kind of just give you a general, simple little problem. I'm going to try to make this not too ugly. I actually accidentally used one of my examples already, but it's all good. So let's say that's my story. Now, you probably already know your vertical stretch factor is -2, but we don't know any of the left, right, and all that kind of stuff. So I could do the opposite b over 2a thing, but I don't want to. So before I do, one of the principles in life is you can do things as long as you don't change what it says. And what I mean by that, like, imagine that you were at Round Table. Round Table has that gaming area in it still, doesn't it? They've like got video games and junk like that. And so, you know, what happens every time a parent goes into Round Table, the first thing that the kid does is comes and begging for quarters, right? How many people have quarters at the ready all the time? Like nobody. So what do you have to do? You have to go up to the cash register and say, hey, can I get some quarters, right? So as a parent, you go take your $5 bill and you hand it to the person at the teller, and what do? They added $5 to their till, didn't they? Is their till going to match anymore? You just gave them $5. They added 5. There's $5 that shouldn't be there. What do? They give you $5 in quarters. So they simultaneously added 5, but they took $5 away. Is the till going to be okay? That's the principle that's going to happen here. So watch how this is going to go. We're going to start by doing this whole thing, which we said never let anything be attached to x. So did you follow what I did right now? I made sure that I started getting things that were attached to x out of there. So far, are you guys okay? No big deal. Now, here's the big, big, big magic step that you really have to watch for. Is we take this term right here, we cut it in half and square it. So what is half of 6? Square it. So we're going to put a 9 right here. Now, mathematically, we just made our cash register out of sync, didn't we? We put a number in there that should not have been there, so we need to make sure we make it right. And the reality, we just subtracted $18 from our cash register. Do you see it? I didn't really move a 9, I moved 18. But it's a -18, isn't it? So what do I do to balance that? If I did this and that, have I kept it in balance now? Now we're good. So watch how that works. There is my story. I completed the square and I have it. Did I ever have to use the opposite b over 2a thing? I never had to go plug back in either, did I? It just took care of itself. So, how far did it get moved? To the left 3 and up a bunch, right? Pretty simple idea, isn't it? So what do you guys think? Is that hard? That was pretty simple, wasn't it? In fact, for me, I like it better than the other one because normally I would have to do opposite b over 2a, which is like this. And then I'd have to take -2 times -3 and square it, and then 12. I'd have to do a lot of order of operations if you're paying attention, don't I? And I got to make sure I don't mess any one of those steps up. And what I did in completing the square, Little bite-sized pieces that were easy to do without making those mistakes. So I would like you guys to do one of those on your own. So your problem is to do this guy right here. You're going to get negative 4x squared minus 24x plus 7. See if you can follow that process through from start to finish and see if you can actually accurately complete your square and do that.
I have a question.
Yes.
Why did we add 18 when 9 times negative 2 is negative 18?
Oh, good question. So the reason we did that is we wanted to be fair. Since this 9 was not there, we had a total of negative 18 that we brought into the story. And what would a negative 18 and a positive 18 do to each other?
Oh, they cancel out. Okay.
Correct. So it's like adding $5 to the register and taking $5 out. It should have canceled itself out, so it doesn't really change the world. Okay? And
Okay, thank you.
so by request, I was asked to make sure that something was available to you, and I figured out how to do that. So the chat is there available now. Took me a minute to figure out how to make that happen, but it's there now. So if you need to say anything, it's going to be available. I probably shouldn't have used the number 24 because unfortunately it's the same things we saw a second ago. Olivia, what's that number right there? Okay, so we're partly there. So what's the magic number that needs to go here off this side? You guys got it? What is it? 9? So then you really have a negative 36, don't you? So what do we need to do to balance that? Sweet. And so it looks to me like my value is negative 4x plus 3 squared and 43. Now that's awesome, that's fine. I rigged both of those problems to be nice. So now I would actually like to not be little kids and actually have a real one. Our vertices are always nice, whole number, easy peasy little numbers like that. Let's do a couple that are actually real. Do you guys know how bad, how nasty the real world is usually when you do real math on stuff? Oh, it does not come out pleasant like that. So I would like to see if we can do one together and you do one on your own where I'm going to take the gloves off a little bit. So I'm going to do 2x squared minus 7x. Now right away I just did something to make the world worse. What is the one thing I just did that's like, oh, that sucks? I made it odd. Dang it. Because I know the axis of symmetry is supposed to be opposite b over 2a. I just screwed it up, didn't I? But watch how easy this is, especially if you have a graphing calculator or any kind of calculator. I'm going to factor out that 2. This should not make anybody in this room quake in their boots. It's really not a big deal. I took this thing. You guys see what I did? Took the 2 out. I divided it. It's a fraction. Who cares? It's not the devil. It's okay. Now, what do we do to this thing right here? Cut it in half, right? So what's half of 7 halves? Well, that'd be 7 quarters. We've square that. I got 49/16. Half of 7 halves is 7 quarters. Got it? 49/16. Well, that's really 49/8. If I multiply it, positive or negative? Right now, it's positive 49/8 if you multiply that. So how do I balance that positive 49/8? Now, first off, hold on. Let's just go through that. Was it hard to take 7 halves and cut it in half? Was it hard to get to 7 quarters? Was it hard to take 7 over 4 and square it? Not really. Honestly, 2 of those was maybe a little bit hard. The hardest part of this entire thing is right now. At the very end, I'm supposed to take 3 and subtract 49/8, right? Now, I know I could do this without a calculator. It's not that hard. But, you know, if you, like, suck at fractions, no big deal. There it is. So my story is that j of x was 2 of these things with a minus 25/8. You guys cool with that? With a minus 25/8? Let's see if you guys know what goes inside. How far did it really move? And the cool thing is every time when you answer that question, what happens when we cut it in half? What's half of -7/2? -7/4. There's my answer, everybody. It's really pretty simple. It's really quite simple every single time you can get there. So what I'd like you guys to try is one of them on your own. Again, you're going to get some fractions, but I did design yours specifically to be a little bit kinder than the one that I just did for myself. So you're going to first need to take that 3 out. And factor that 3 out. Watch really, really carefully what's happening. Can I get a volunteer for what happened right there? Anybody willing so I don't have to call on somebody? What happens when you factor out that -3? Anybody have it?
4/3 x.
4/3, you got it. It's a positive or is it a -4/3? It should be negative, yeah. Okay. Now, by the way, have we actually mathematically changed anything right now? If you distributed, do we still have the original question? I think we do. Let's see. Jason, oh, I was going to call Jason, sorry. Just beaming. What happens if you take that thing and cut it in half? What's half of 4/3? 2/3, thank you. Love that. By the way, a lot of people want to say 4/6, but we could reduce it. 4/3 is 2/3. That's no big deal. Can you square 2/3? What'd you get? 4/9? Yeah, 2/3 squared is 4/9. I always change colors on that one just to emphasize that we just did something weird. You ever notice that you ever notice that when you give somebody something, you ask for change, you ever notice that a lot of the tellers will take that bill and they'll set it sideways right up on the top and they won't put it in until after they've given all the change? Because they're wanting to make sure they're being really careful, especially given like a $100 bill or something. They're always super careful. So let's see. Jacob, would you be able to fix that one for me? Because that 4/9 was not supposed to be there. Why it's red. You're supposed to add 4/3. You're right. Because when you multiply this, 4/9 times -3 is -4/3. So you said, let's add 4/3. That's perfect. And so we're pretty much good to go. And if we are right, well, that's a third. That's not for us, is it? No, that's the other group, yeah. Oh, well, wait a minute. What was this right here? This was a negative, so we added it. Could somebody else different tell me what actually happened here? This is a little bit screwy. This messes with people's heads a little bit. And I actually really, really, really like the way Cameron said that. Because you said half of -4/3 is -2/3, right? So what goes inside? Yeah, whatever number you said when you cut it in half, it worked every time. Now, just for fun, I have had a number of students tell me that they always have Desmos open while they do their homework. And I would really honestly love it if I heard that that was more of you guys than it probably happens right now. That's the original equation, isn't it? So when we do yours, what should we have? We better get the same thing, right? So is there room for errors in these problems? Look at it. Is there a few places you could make a stupid mistake? I mean, I would. I'll admit it. I make dumb mistakes all the time. But if I have done this thing well, I hope as I go through this whole process, I'm actually doing all right. Oh, that was plus 1/3, wasn't it? Did you nail it? Did it actually give you literally the exact same graph? So if you want to practice it, you can make sure that you're doing really, really, really well. Okay, now let's go ahead and take it 2 more things. Okay, so for starters, to recap what I wanted you guys to be able to do. Number 1, I would like you to take it from the nice form and be able to graph. Can you guys do that? Number 2, I'd like you to be able to take it from the incorrect form and put it into the correct form, either using opposite b over 2a or using completing the square. Okay, I got 2 more things that I need you to do, and that is to find the quadratic. And this is the last stand of my story. We're going to try to find a quadratic, and this is going to be kind of interesting. The first one is easy. The second concept, a little harder. So here's the first one. I've got the following. My quadratic has a vertex of -1, 7, and it passes through the point 2, 1. Now, we did this when we had lines, didn't we? Didn't I give you sometimes 2 points and then we'd find a line?
Excuse me, Mr. Penner.
Yep, back to the share again.
Yeah, we can't see the paper. We only see Desmos. So.
Yep, I gotcha. So I'm fixing it right now. There we go. Thank you so much. Thanks for reminding me, Kevin. Okay, so we're right here. And it seems like there wouldn't be enough information, right? But we know something. Anytime somebody hands us the vertex, then I know that this graph got pushed over 1 unit to the left and up 7. What's the only thing that someone never told me? I don't know, the stretch factor, right? So literally in this one thing, didn't it give me most of the parabola? I just have 1 piece to go. Now, what have I never used? I don't think I ever used that point, did I? So could I plug that point in now? X is 2 and Y is 1. So if I put a 1 in here for Y, and if I plugged in the 2 for X, that'd be 2 plus 1 squared. Can you guys help me find out what A is then? That's not too bad. So that's 1 equals 9A plus 7. So it looks to me like if I divide it by 9, I get -2/3, is it? Now, could we check that answer pretty easily? What should happen if I did it right, if I graph that? What should be on it? Those 2 suckers, right? That's pretty easy, isn't it? So can you guys do one of those for me? I'm not going to do a lot of these. Your problem that I want you to try has the following. You're going to get a vertex of, I'm just going to go with 4, -3. And it's going to go through some point P somewhere else on the graph. Your point P is going to be the point 1, 11. So let's see if you can come up with a thing that has that vertex and goes through that point. And then for the last question, I'll have to take the gloves off. And we'll do the really hard problem. Just kidding, it's not that hard. so hopefully you guys started there, right? Just use my vertex. I knew it went to the right 4 and down 3. So what do we have to do next there, Maisie? Yeah, let's plug in the points. So I know that y is 11, and I know that x was 1. So what's this really going to be? Isn't that 9? I mean, I'm okay if you guys kind of cut some steps. So can we get that pretty quickly? What do you get for a? Ooh, I got 14/9. Did you get that? Ooh, that's kind of nasty. A is 14/9, but that's not that bad. I mean, we have our answer, and it's no big deal. So why did we get away with such a little amount of information? Guys, wouldn't 2 points normally make a line? Why was 2 points enough this time? What was one of the points that I gave you, though? One of them was the vertex, wasn't it? So didn't that kind of give you 2 pieces of it? Because it told me the up and down and the left and right both, right? Well, here's the last little piece to do. This one is rough. I will say that at first glance, this one is a little bit rough. So I'm going to go ahead and try to make the first one fairly kind, but then it's going to get a little bit nasty off of that. So here we go. You guys are going to have the following story. I have a parabola. This is the end game. This is the last thing. I have a parabola that goes through the following coordinates. Sorry about this, everybody. This is a little rough. At first glance, this is going to look a little bit rough. So we're going to find a parabola, find the quadratic through these. But guess what I'm not telling you? I'm not telling you the vertex. I'm not saying anything. And in fact, if I don't give you the vertex, it takes 3. It just does. So here's kind of the protocol that we're going to do. I don't really know what it's going to be. So I start with this. I start off with a good old-fashioned quadratic. I think you guys did this in Algebra 2. I'm pretty sure you did this in Algebra 2 back in the day in a certain spot. So this may remind you of something, but watch how this works. What happens if you plug in 3 for x? What do you have right here? Don't you have 9a? What happens if you plug in 3 for x right here? You get 3b, don't you? And c doesn't change no matter what. It's always that. And the answer for y was supposed to be 9. Wasn't it? Now, let's see if we plugged in -2 for x. What do you get if you plug in -2 for x? -2 squared? 4a. -2 times b. And it says the answer is 24. What's the last one? See if you guys can give me the last equation. What happens when we plug in 5? It's 25a, then what? 5b. Oh my word, how are we going to solve that? Can we go back to what we did not too long ago and look at the Desmos Matrix thing? Let's do that. Let's go ahead and play a little Desmos Matrix game. Let's see if the calculator will do all of that work for me, because I don't really want to do all that work. It's going to be right here. So my Desmos Matrix, please take one out, because I'm going to make you do one on your own. Oh man, we need a new matrix. How big is my matrix? How many rows, how many columns? Pretty sure I had 3 rows. How many columns? 4. And so we went 9, 3, 1, 9, 4, -2, 1, 24, and 25, 5, 1, and 31. So we get all that data in there. Am I done, by the way? Did I get it all in? So we have to tell my computer I finished. Now what? See if you guys remember the last step to finish it. Christian, do you remember it? You don't remember it? Anybody remember? There's one of these buttons here that's a really helpful little thing. Yeah. It's RREF, you got it. So let's do the row reduced on A because that's what I called my matrix. And there's my answer. Huh. So what is it telling me that A is? It's saying that A is the number 2, isn't it? So we called A, so that was 2x squared. What's it saying B is? It's off to the side, so I can't see it very well. Is that -5 or -3? So minus 5x, that was the B, and then the last number was 6. So if I were to graph this, I would actually find absolutely perfectly that this is the equation that would actually nail those 3 points. Isn't that kind of cool? Just setting up a quick matrix. I want you to do one on your own, but I'm going to be mean. And then I'm going to stop, okay? So do you guys all have your graphing calculators or Desmos Matrix out, all that kind of stuff, because you're going to need it. So here's what you got. What's that? I just Googled Desmos Matrix and it just pops up. There's probably a faster way to get there, but I just use that. So here's what I want you guys to do. This one is nasty, by the way. If you were doing this by hand, you would be angry at me, but I'm not making anybody do it by hand. You got -1, 6, simple coordinate, 2, 11, and 6, 2. Let's see if you could set this thing up, accurately go through. You gotta first make sure you make the right 3 equations so you can set up your matrix. And if you can, we're gonna be in good shape. Bryce, can you give me the first equation just to make sure we're all in good shape? What'd you start with?
1a minus 1b plus 6.
I like that. That's good. Evangelina, did you get the second one? Do you like the fact that there's always just plus C? We don't have to do anything with that one. Christina, did you get the last one? Okay, so I hope you guys all ended up with this little story right here. Again, I'll do a quick share because I also have that exact same matrix you guys got. Now, one thing that happened when I did that is, did you get a nice answer? Oh my gosh, it gets a terrible looking answer. Really, really, really unfortunate. I got to see if I could shrink this down so I can actually get to the point where I can enter my matrix. But I wanted to do row reduced on A, and it looks awful, doesn't it? Did you guys notice a little fraction bar off to the side? So it's telling me that the equation of my story was actually all done right there. So it says A should be negative 47 over 84, which is pretty bad. Did I mess something up? I feel like I messed something up. Is that right? Okay, I must have written something down. No, I didn't. Okay, let's do a stop share, do a new share to this thing right here because this tells you what you need to know. So that's what I got. That's what I got right there. Negative 47 over 84, 187. That's terrible looking numbers, aren't they? But it doesn't matter. Could you, by the way, graph that and graph those 3 points? So will it hit them all? Should. And by the way, that's your assignment. Okay, so it's going to start very, very easily. These first 6 questions, there's a list of equations in vertex form, and there's 6 graphs. Guess what you're going to do? You're going to match them up. Look at the vertex, look at how they open. It's easy peasy. See over here, you've got a couple of problems where you're going to use opposite b over 2a to get into vertex form. There's a couple of problems you're going to use completing the square to finish. And these usually mean if I add a couple of extras down at the bottom, that means they're probably some application problem, like a rock got thrown or something like that, and you're going to answer a question about it. So usually if I have a cluster of extra little questions, it's a word problem or something that I want you to look at. So in Google Classroom, find chapter 2. You'll see the textbook chapter 2. Click on it. Go to 2.1. You guys have 20 minutes. Try to get a couple of them done. I'm pretty sure you can easily get those done and maybe even 1 or 2 of those, okay? So the rest of the period, 20 minutes, is yours to get a little bit of work done, everybody. And I hope that was, I know it was a little long, but hopefully it was helpful. Absolutely. All right. So it's just work time now, and you